There is a specter that is haunting the motherland. This specter is known as calculus, and it has the power to deunify us. This is what the revolution is doing. The revolutionaries have blind hope because the spirit of calculus is dead. We must fight back and snuff out the rebellion.
Calculus is not dead. We need to find the math spirit.
Ha! Stupid children. Unless they know the 6 calc trials, they'll never get the spirit of math.
Bubbles, you're good at pushing limits. I'm sure you'll be fine for this first trial.
Okay, so for asymptotes, you have 2 types. There's a vertical and a horizontal. For vertical asymptotes, you take the limit as x approaches 0 of f of x over g of x, and to see where it equals positive and negative infinity. And then with the limits, if it's a positive number over 0 from the right, it's infinity. And if it's a negative over 0 from the left, it's negative infinity. For horizontal asymptotes, you take the limit as x approaches positive or negative infinity of f of x over g of x, and see where that equals c. And if c is also where the horizontal asymptote is at, then you need to check both sides for end behavior. For continuity, there's 3 things that need to be true. You have to have a value of the function at the point. The limit as x approaches a from the left has to equal the limit as x approaches a from the right. And f of a has to equal the limit as x approaches a. And then on this function, there are some types of discontinuity here. This is a point discontinuity, and that's a jump discontinuity because you have a bridge or a gap between the 2 points. And so for this one, if you wanted to take the limit, you could take the limit from the left and the limit from the right. However, because the 2 limits don't equal each other, they're not continuous. The regime unleashes a new weapon, and all of the resistance's tools haven't been able to stop it. Go, Josh.
Hey, maybe my tactics can be integral to what we're doing. Oh, I recognize this. It's the graphical representation of an integral. It's just the area under the curve. That's easy. Oh, but this is even tougher. This is the trapezoid rule. This is what used to approximate the integral. It's usually used in accumulation, like LREM and RREM and midREM. And those are just summations. Oh, the motion. This is another integral. This is great. I love this stuff. The total distance is found in the integral of the absolute value of v of t, which means that it's just the area above the curve minus the area under the curve. We know that displacement's f of b minus f of a because it doesn't care about vectors. Speed is just the absolute value of v of t, and speed increases when v and a have the same signs, while it decreases while they have different signs. Right, up, left, down. Just gotta remember that. For vectors, we know that the velocity is just the derivative of your position function, and your acceleration is the derivative of that derivative of the position function. And we know speed is just the summation of the velocity vectors in the x and the y direction. So this makes sense. It's Pythagorean theorem. And distance, we already figured out. It's just the final and the initial time, and we know it's in terms of t because it's a parametric function.
These derivatives should stop them in their tracks.
Derivatives. Wait, Shalyn, didn't you study this before?
Yeah, don't worry guys, I got this. So for rate of change, it's f of b minus f of a over v minus a, and the instantaneous rate of change is the derivative, which is f prime of x, which I'll get into later. Definition of derivative is limit as h approaches 0 of f of x plus h minus f of x all over h. And the alternate form is limit as x approaches a of f of x minus f of a all over x minus a. Now here's a tangent line. Here we need our point and we need our slope. Our slope is f prime of c. So the equation for tangent line is y minus f of c equals f prime of c, which is the derivative, which is the slope, times x minus c. Now, we covered limits earlier, and in some cases, as of this one, if the limit as x approaches a of f of x over g of x equals 0 over 0 or infinity over infinity, we have to apply the L'Hopital rule. Then, the limit as x approaches a is the derivative of f over the derivative of g to get our answer. And in some cases, we may need to use this rule multiple times. Some problems are special, such as parametric and polar, which I'll cover soon. So to find the slope of a parametric function, dy dx, it equals dy over dt, which is the derivative of the y function, over dx dt, which is the derivative of the x function. For double prime, we have to find ddt of dy dx, so the derivative of dy dx, over dx dt, which again is the derivative of the x. Lastly, we have derivatives of polar. dy dx equals dd theta of r sine theta over dd theta of r cosine theta. Oh, guys, it's integration. Don't worry, I got this as well. So, if f of x is any function such that capital F prime of x equals f of x, then the integral of f of x dx equals capital F of x plus c, where c is the arbitrary constant called the constant of integration. You need that c here because there are no bounds on the integral. Now, there are different methods for integrals. If unrecognizable, we have to simplify to a recognizable form. And if it's inside, we have to use u sub. If a product of function, we have to use parts. If the denominator can factor, partial fractions. And if a denominator cannot factor, we have to complete the square and always check for inverse trig. Oh, fundamental theorem of calculus. So there's two parts to this one. The first one is the integral from a to b of f of x dx equals capital F of b minus capital F of a, and capital F of x is the antiderivative of f of x. Part 2 is the derivative of the integral from c to x of f of t dt equals f of x, and we have to remember chain rule because there might be something within that. Lastly, particular solutions. So, say dy dx equals f of y times g of x. First we have to separate the y's from the x's, and then we integrate to solve.
Cheryl, use your series power. You can do it.
So series, it's the sum of an infinite sequence. This is a geometric series. So when r is greater than -1 and less than 1, it converges, and otherwise it diverges. So when we're looking for the sum of a geometric series, we just find the r, which is 3 over 4, and we use the first term divided by 1 minus the r, which in this question is 3. Divergence test. So we set the limit n to the infinity equals, if it doesn't equal to 0, it diverges. If equals to 0, we know nothing and try another test. We can compare the series with the integral. And if the integral converges, the sum converges. If the integral diverges, the series diverges.
How do they know how to do series? Like, I don't even know how to do series.
Oh, applications of dy over dx. Well, it's not that hard. Locoestrema. So, in order to find locoestrema, we can use first derivative test, which is using dy over dx equals 0 to find the critical point. And then we plug in the number line. When f prime of x changes sign from positive to negative, that means we find the relative maximum point. And if it changes sign from negative to positive, then we find the relative minimum point. So, and there's second derivative test. If f double prime of x bigger than 0, then we find the local minimum point. If the f double prime of x smaller than 0, then we find the local maximum point, and that x is the critical point. Okay, so absolute estrema, it's really similar to the locoestrema. First we find critical points, and then we plug each endpoint and each critical point into f of x, and the biggest value will be the absolute maximum point, and the smallest value will be the absolute minimum point.
Time for me to step in.
It's for calculus!
Hello, darkness, my old friend. I've come to talk with you again, because a vision softly creeping left its seeds while I was sleeping, and the vision